The transport layer of the TCP/IP stack should be easy to remember because it maps to the same name, the transport layer of the OSI model. And the two primary protocols found at the transport layer in the TCP/IP stack are TCP, Transmission Control Protocol, and UDP, the User Datagram Protocol. First, let's examine the header of a TCP segment. Notice that we have source and destination ports. These ports, they identify to which upper layer protocol data should be forwarded, and from which upper layer protocol data is being received. The window size says how many bytes can a receiver receive before they expect an acknowledgement. This is a way to do flow control. Remember what flow control is? Flow control is a way for the sender to be told to slow down because it's transmitting too aggressively. You see, the sender can start out with a small window size, let's say one segment, and if that segment is delivered successfully, as evidenced by an acknowledgement that we receive, we could double the window size. We can go to 2 segments, and if that is successful, we can double again and go to 4, 8, 16, 32, 64, 128, 256, 512, 1024, and so on and so on. In fact, the current standard allows us to have over 2 billion bytes that we can send before we expect or require an acknowledgement. But the window size can grow over time. If we get to a point where we are sending too aggressively and a packet does get dropped, the receiver, when it sends an acknowledgement, it can say, I acknowledge that I received this segment and this segment, and I want this next segment, and then the sender could see that, whoa, I've already sent that segment. It must have been dropped. I must be sending too aggressively. That can cause the sender to reduce its window size. That's something called TCP slow start. We also see that we have a sequence number field. This allows segments to be put back in the correct order if they arrive out of order. There is an acknowledgement number. The acknowledgement number indicates the next sequence number that the receiver expects to receive. And this is a way that the receiver lets the sender know that all the segments up to that sequence number have been successfully received. In addition to TCP, we said the other big player at the transport layer was UDP, the User Datagram Protocol. And the first thing we're probably going to notice here is it's much smaller. It has a lower overhead. That's one of the big benefits of UDP. TCP, it's considered a connection-oriented protocol, or in other words, it's a reliable protocol. If we send segments, we get acknowledged that those segments were successfully received. And if they were not, we can send them again. So it's a reliable transport mechanism. UDP, not so much. With UDP, we don't have a sequence number. We don't have a window size. We don't have an acknowledgement number. This is a connectionless protocol. There is no acknowledgement. Therefore, it is referred to as an unreliable protocol. And I know that might sound bad, but there are certain applications where this is actually a good thing. For example, if you're sending streaming audio or streaming video, you probably don't want to introduce the delay of when you have to wait for an acknowledgement. And if a packet gets dropped, I have to retransmit. That could lead to excessive delay in an audio or video stream. If we send audio or video using a UDP, for one thing, we don't have to worry about the big overhead. We have a much smaller header size. We have a more efficient use of bandwidth. And we really don't care if we're not told about a dropped segment, because honestly, we don't want to retransmit it anyway. If we waited for that acknowledgement, it would introduce significant delay into the transmission. And I've experienced this. I used a streaming audio program that was designed to use TCP as the transport, and it was where multiple participants could participate in this audio conversation. And we noticed that after we had been in a conversation for some time, and based on network conditions, a few packets had been dropped, there was a delay in our transmissions. It started to not be real time. We started to talk on top of each other. It was not a good thing, and that's because TCP was being used. We were waiting for acknowledgments, we were retransmitting drop packets. That's not good. That introduces delay. So UDP, it's actually a great solution for something like streaming audio or streaming video. We don't have many fields. We do have source and destination ports, much like the TCP header did. There is an optional UDP checksum, which can detect errors, and the other field is a length field, which says in bytes, how big is this UDP segment?